A rectangle is inscribed with its base on the x-axis and its upper corners on the parabola y equals 5 minus x squared. What are the dimensions of such a rectangle with the greatest possible area? So I think it helps if we take a look at a picture. 5 minus x squared would have a vertex at 5, and if we sketched it, it would look something like this. We want to make a rectangle whose one side is on the x-axis, and then the height of the rectangle is going to be up to where it touches the parabola. So we want the area to be maximized. So what we're trying to figure out is what x value would make that happen. So this is an x value down here, and then the point right here would be y equals 5 minus x squared. Well, if this is x over here, then you're going to have negative x here, and the total length would be 2x. The height or width, whatever you want to call it, would be from the x-axis up to this point, the 5 minus x squared. So 5 minus x squared equals I'm going to call it the width. Area is equal to length times width. So we get our area function. We get a of x is equal to 2x times 5 minus x squared. That's equal to 10x minus 2x cubed. To maximize area, you want the derivative, which is 10 minus 6x squared. Then we need to take the derivative, set it equal to 0, and solve. Let's add 6x squared over to both sides, and we get 10 equals 6x squared. Divide both sides by 6, and we're going to get that x squared is equal to 10 over 6. That's the same as x squared equals 5/3. So x is going to be the plus or minus the square root of 5/3, but since we're talking about dimensions here, we'll ignore the negative. 5/3 is about 1.291. We have to go back to our original length and width, length being 5 minus x squared. So that's 5 minus 1.291 all squared, and that comes out to be about 3.333. Then if we plug it into remember width was equal to 2x, so that's going to be 2 times 1.291. So the width is 2.582.